Okay, so this is the continuation of lesson 1.2 for Mrs. Cucci's Precalculus Now class. You should be on page 1.26 or 1.26 of 1.2 in your calculators. Okay, so what we're going to be talking about today is visualizing domain and range. We talked about what actual domain was and range was yesterday, so I want to continue down that path. When we're talking about visualizing domain and range, we have to keep a couple of things in mind. You have to remember that domain is the set of function inputs, or the values that we find on the x-axis, the horizontal. Range is the set of the function's outputs, or what we find on that vertical axis, which we call the y-axis. All right, so this is just a reminder of that. What you're going to notice is in blue, as I move my point, nothing's working for me. As I move my point P, the blue point that's moving, that represents your domain, okay? And your red point represents your range. So you can see where the blue and the red are traveling, okay? Or where your domain and range will extend. All right, so thinking about it graphically, what is the domain of 1/2 x plus 1? So what I want to do here is I want to insert a graph, okay? Control I, add graphs. And again, it was 1/2 x plus 1, so we're going to type that in, 1/2 x plus 1, okay? And we look at my graph. Now my graph is linear, so we want to think about what my domain is, okay? So what values of x, what are my input values, or what values on the x-axis are being utilized? Well, if I look here, I've got a point here, and then I've got a point here, and I'm using every single value on that x-axis, okay? So the way we'd represent that would be from negative infinity to positive infinity, okay? Your range, meaning what we're using on that y-axis, is very similar. You're going all the way again from negative infinity to positive infinity. We're using every value on that y-axis. Okay, so there's your domain and your range. All right, so let's get a little bit harder. Square root of x plus 4. So we're going to add a graph page. We're going to graph it. And here's what it looks like. So let's start thinking domain. What values on the x-axis are being used? So from this point here, all the way, as it continues on, those are my domain values. So my domain is going to be from negative 1, 2, 3, 4, all the way to infinity. And now for range, what values on the y-axis am I using? Well, I'm using the value of 0, right, from here. And this function does continue up. It continues up forever. So that's going to go all the way up. So my values for, and I apologize, this should be a closed bracket. Sorry about that. My values for my range are going to be from 0 to infinity. Okay. All right, so x cubed minus x. Let's take a peek at that one. Okay, here's my graph. So what this graph is doing is it's extending down to negative infinity, but as it extends down, it is widening from that y-axis, so it is going to continue to spread out. Same thing going on up here. Okay, it is expanding up to positive infinity, however, it is widening. So if we want to talk about the domain, what values of x are being used. Now I know on the graph it looks like we're using very little, but we have to think about in terms of infinity, how large that's actually getting. What's happening to this graph is it is expanding outward to to further x values and negative x values. So this actually does span from negative infinity to positive infinity. Now the range is easier to see because it's spiking up to positive infinity and it's spiking down to negative infinity. So again, that's also negative infinity to positive infinity. Okay, 1 over x minus 2. Control I, add graphs. 1 over x minus 2. So now some of you should already be thinking, I know what value makes this function undefined, so I know I'm going to have an issue with my domain, right? So here's my graph. So let's talk about domain first. Domain is all the values of x that are being used. Now, it looks like we're coming from negative infinity, but then I seem to be stopping and heading down at what value of x? Okay? Remember that dotted line is called an asymptote. Okay? We have a vertical asymptote at x equals 2. Okay? So it looks like my domain, I'm using all those values of x from negative infinity all the way to, but not including 2. And then we're picking back up and going all the way again to positive infinity. Okay, so again, open brackets here and here because we're not including that value of 2 because we have an intercept or asymptote at 2. Okay, now I want the value of 1.9999999. The function exists there. I don't want the value of 2. That's why we use that open bracket. Range. Okay, well, we're spiking up. We're spiking down. All right, does the function exist at 0, at y equals 0? Can I get y to equal 0? That's the kind of piece I need to know. I know it's going to shoot up to positive infinity and down to negative, but can it ever equal 0, this x-axis, right? So here's what we can do. You can set up your proportion. 0 equals x over 1 over x minus 2. Cross multiply. 0 times x minus 2 is 0. Does 0 ever equal 1? No. Okay. So y can't ever be 0, which means it's not going to be part of my range. All right. So we're going to go from negative infinity to 0, and then from 0 to infinity, but not including that value of 0. So that one's a little bit trickier, but you just pull it apart piece by piece. Okay. Domain of x to the 4th minus 2x squared minus 3. I'm going to add in that graph page. Here's my function, x to the 4th minus 2x squared minus 3. Graph it. And here's our x to the 4th function. And you do need to become very familiar with what a quadratic, a cubic, okay, x to the 4th, x to the 5th, what those functions look like. So you should be able to look at this and know it's x to the 4th. You should be able to look at a graph that looks like this and know that, that's a terrible one, know that it's x cubed. Okay, so these should become very obvious to you. All right, so we're going to start with domain. What values of x are being used? Now think about what's happening to this 4th root. These are widening as we increase. Okay, so they're getting bigger and bigger and bigger. So the space that they're using on this x-axis is spreading out. So that means that your domain for this is going to be from negative infinity to positive infinity. This 4th root is going to continue to expand and open up so that it's using those values of x. Your range, on the other hand, is restricted. Restricted means we're only using certain values, okay? It looks like this is my lowest value on the y-axis, and then it's spiking up. So I know that I'm going to positive infinity, but I want to know what my minimum value is there. And it's pretty easy to just count and see what that is. We're looking at -1, -2, -3, -4. And we are using the value of -4, so we do want to include it with that square bracket. If you're not sure if you're using that value of -4, you can pull up that table and see what value is going to be your minimum value, or you could use point on and find the minimum point, and that would give you an idea of what value of y you're using. As a matter of fact, let's take a peek at what that table looks like. Okay, so here's our table. And if you notice, value of 3, 60, then 5, -4, -3, -4, 5. So the smallest value for us is going to be a -4. Okay? All right, here's a bigger, uglier one, right? What is the domain? So we're going to take this. We're going to add in that graphs page. We're going to graph that function. Square root of 4 minus the quantity x minus 3 squared. And here's our graph. Okay? What it is it's half a circle. It's a semicircle. Okay? So my domain values are the values of x that are actually being used. Now, when x equals 1, we're not really sure if that value is being used. I don't know if that's touching the x-axis or not. Same thing over here. I'm not 100% sure, so I need to make sure that I check to see that those are part of that domain. So I'm kind of thinking from 1, 2, 3, 4 to 5 right now, but I'm not 100% sure what kind of brackets to use. So we're going to check those values. So we're going to check 1 to start, and all you're going to do is you're going to plug it in. Remember, you cannot have a negative underneath a radical. So we get 4 minus 1 minus 3 is -2 squared. 4 minus -2 squared is 4. And we get the square root of 0. And that exists. We can use that value. So 1 works for us. Let's check 5. 4 minus 5 minus 3 squared. 4 minus 2 squared. Again, square root of 0, so we're using that value as well. So my domain is from 1 to 5. And there you go. Okay. We can very quickly, if you want, just check that range, and that is going to go from 0 to 2. Okay, so hopefully these are becoming easier. All right. Linear expansion of a bridge. A linear expansion L of the steel center span of a suspension bridge that is 1,420 meters long is a function of the change in temperature T in degrees Celsius from winter to summer and is given by L of T equals 0.000013 times 1,420 T, where 0.000013 is the, not K, sorry about that, coefficient of linear expansion for steel, and L is in meters. Find the linear expansion of steel center span when the change in temperature from winter to summer is 30, 42, 50, and 56 degrees Celsius. Okay, so I know that it's very wordy, but it's really very simple. Okay, I have a function. Now all I have to do, because I have the temperature values, T, all I'm doing is substituting those values in. So we can do this one of two ways. Well, both ways. We can graph it and look at the table for those values, or we can store and plug in. So either option is fine with me. Okay? So I think what we're going to do, since I've been talking about visualizing, is we're going to graph it. So here's the function that I'm concerned with. Okay? And what I'm going to do is I'm going to add that graph. I'm going to put it in. And remember, I want it to be x, not t. And we're going to graph it. Okay? Now, it's not a very nice looking bridge because if we think about it, this isn't really what it's going to look like, is it? Okay? If we think about the expansion of the bridge, we're probably not talking about 10 meters. We're probably talking much larger, right? So let's see if I make this 100, if that makes a difference. So now we're starting to see, okay? So we want to know the values of temperature at 30, 42, 50, and 56. Very easy way to do that is to hit Control T and then simply go to those values, okay? Now, it would be nice if we didn't have to scroll down, which there is a way, but we're going to just suck it up and do it. So here's my first value, 30. All right, remember that's in meters. Be 0.5538 meters. 42. 0.77532 meters. 50. 0.923 meters. And then 56, 1.05222 meters. Okay, so it was very simple to do because we knew where to find those values. Okay, so L of 30, 0.5538 meters. L of 42, 0.77532 meters. L of 50, 0.923 meters. And L of 56, 1.0338 meters. Okay, so again, come prepared with any questions that you may have tomorrow, and I will see you then. Thanks, guys.